So for problem number 3 gives us 3 different series, and we need to apply ratio test to each one of them and figure out if it's convergent, divergent, or inconclusive. So looking at the first one, I'm going to go ahead and apply ratio tests to it. So I take the limit L is equal to the limit as n approaches infinity of the absolute value of a sub n plus 1 over a sub n. Okay? So I'm going to go ahead and I'm going to plug into that formula. Remember, a sub n is just whatever is inside of your series. So my a sub n plus 1 in this case becomes n plus 1 quantity squared over n plus 1 to the 8th plus 1 times n to the 8th plus 1 over n squared. Okay? So I need to go through and I need to figure out what happens to that ratio. So already I know that this term is going to be some sort of n squared. So it's going to have n squared plus some other terms to it. So I'm just going to go ahead and write it as that, because all we really care about with polynomials is the leading term. The leading term is going to reach infinity faster. So therefore, I'll write out n squared and leave the rest of those terms just as some extra terms that we don't care about. The next term will be n to the 8th plus 1. Can't really do anything about that. We just kind of have to leave that there. If I look at this term down here, I have n plus 1 to the 8th. Again, just like I did with the n plus 1 quantity squared, I'm just going to go ahead and factor out at least the first term. So I know I end up with like an n to the 8th, but then I'm just going to leave it as a bunch of extra terms that, again, we don't really care about because, well, again, frankly, it's going to infinity, so n to the 8th is going to reach it faster. There's also a plus 1 in here, so don't forget about that plus 1. Then we have an n squared term down here. So if I go ahead and I multiply those terms together, again, it's going to be a lot of multiplication, but all we care about is the first term as n goes to infinity, and also limit as n goes to infinity. So in that case, I end up getting n to the 10th plus a bunch of additional terms, and on the bottom, I also get n to the 10th plus a bunch of additional terms. Now for polynomials as n approaches infinity, these are both going to reach infinity at the same time. So the ratio here is just 1. So what that means is that my L value for this came out to 1. When L comes out to 1 for ratio test, that means that it's inconclusive. So this first one, I'm going to denote an I next to it for inconclusive. Again, we're not trying to prove convergence overall, we just want to use ratio test and see what the outcomes are. Number 2, we have 1 over natural log of n. Okay, well if I go ahead and I apply ratio test to it, as n approaches infinity, the limit, I have 1 over natural log of n plus 1 for my first term in the absolute value bars, times natural log of n over 1. Okay, cool. So, if I go ahead and take the limit of this as n goes to infinity, all I end up with is I end up with 2 natural logs on top of each other. And as it turns out that natural log to the n plus 1 and natural log to the n, the constant doesn't really affect it because, again, all we care about is the n terms as n goes to infinity. So these are growing at the same rate. Because they're growing at the same rate, we end up with 1. And a way you could prove that is it's indeterminate, so you could use L'Hopital's rule. You end up with 1 over n plus 1. That's equal to n plus 1 over n. Take the limit again of that as n approaches infinity. It's still indeterminate, so you end up with 1 over 1. 1 is your final result. So, in this case, my final result for L is equal to 1 for this one as well. That means that ratio test is still inconclusive. Number 3. So for number 3, again, just apply ratio test to it. So L is equal to the limit as n approaches infinity of n plus 1 to the n plus 2. So n plus 1 is n plus 2 over n plus 1 factorial. And then that's times a sub n reciprocal, so that ends up being n factorial over n to the n plus 1. Okay, so we can go through, we can cancel out a couple things. So first off, I see the factorial. The factorial, remember, you can always reduce those down by using the rules of factorials. So this becomes n plus 1 times n factorial. The n factorials end up canceling, and I'm left with just an n plus 1 on the bottom. So for these terms, it's going to take a little bit more work to try to get them out. But what I can do is I can say that n plus 1 to the n plus 2, I can break that up to different powers. So what I can say is that this is equal to n plus 1 to the n times n plus 1 quantity squared. So powers to the same base, you can always split them up to the same base and multiply those terms together. So if I have n plus 1 to the n plus 2, that becomes n plus 1 to the n times n plus 1 to the 2. Okay, same thing down here. I can also split this up, and I can say that n to the n times n will give me the result. And this is also n to a first power. So n to the n times n to the 1 gives me n to the n plus 1. So now that I know this, I can go through and I can cancel out a couple terms. This n plus 1 cancels with one of these up here, so that makes that a little bit easier. And now, what I'm left with in this case is I'm left with n plus 1 to the n times n plus 1 over n to the n times n. And I need to figure out what that series is going to do as n approaches infinity. So, in this case, I have n plus 1 over n. Again, those are polynomials, they're growing at the same rate. So I'm just going to say that the limit of that as n approaches infinity is 1. But I'm still left with this term here. So if I go ahead and I rewrite that out, L is equal to the limit as n approaches infinity of n plus 1 over n, all to an n power. Now, the reason I can do that is, again, these are both to n powers, so I can go ahead and just condense them down into one exponent. So if I go ahead and I simplify this out, I end up getting the limit as n approaches infinity of 1 plus 1 over n to the n. Now that limit is already predefined. It's been done in class, and there is a proof for it. The limit of this, as n goes to infinity, is e. So the limit of this, as n goes to infinity, is e. E is greater than 1. So therefore, by ratio test, this is divergent. So I got inconclusive, inconclusive, divergent, which means that the answer is B.
The Teaching Center, UF's Learning Resource Center.